In number 5, I've set up the equation down here in the space that we have to work in, and I've already written RICE for reaction initial change equilibrium. In the problem, it tells us nothing, essentially. It doesn't tell us any of the concentrations or any of the other information that we need. But since it's a decomposition problem, and since we start with a solid, we know that we can ignore the reactant, that it doesn't matter, and that we care about the products. And since it's a decomposition, we can assume, oh, the products at the beginning were zero. So the initial amount of each of them was zero. When the reaction happens, there's a coefficient of 1 here, so we're going to be plus x. Only one x, not 2x or any other amount. And here, it's also plus x. So that at equilibrium, we have x. That 0 plus x gives us x. Notice there's almost nothing in this table. Where the power of the equilibrium expression is going to come into place is when we actually do the equation for equilibrium. So we got Kp is equal to the products, which is H2S times NH3, over the reactants, except there is no reactant that we're going to include in the equilibrium expression. Remember, it's solid. So since it's solid, we're not going to include anything there. All right, so Kp is going to equal x times x, which is x squared. Again, it's x times x. All right, we know what Kp is, luckily, though. It's 0.11. So the amount of x is just going to be the square root of 0.11. And the square root of 0.11 means that x is going to equal 0.33. Now, we're not dealing with molarities here, we're dealing with pressures, and so pressures are in atmospheres. All right, so x is 0.33 atmospheres. That means the amount of H2S is 0.33 atmospheres, and the amount of NH3 is 0.33 atmospheres. All right, but the problem asks us what the total pressure in the flask is. Since there's two products and they're each 0.33 atmospheres, the total is the total of those two, so 0.66 atmospheres. All right, that's the answer for A. So the answer for A is 0.66 atmospheres. All right, in B, what's Kc? We can write down the equation where we can convert between Kp and Kc. All right, and in this case, delta N, we're talking about the change in moles in gas. And so the change in moles in gas, we had no gas before, we have 2 moles of gas afterwards because we have the two products, remember? So delta N is going to be to 2 this time. We know what R and T are equal to. R and T are equal to 0.0821, and the temperature is 298 because it's 25 degrees C. Raised to the 2. We don't know what Kc is, we're trying to solve it for it. And we know that Kp is equal to 0.11. All right, when we do the algebra out to solve that, we get that Kc is equal to 1.8 times 10 to the negative